Today we're going to be talking about simplifying and multiplying and dividing irrational expressions. Now, we talked about the rules of exponents a while ago, and we're going to be revisiting those and applying some of those today. So a rational exponent or a rational expression is in simplified form if its numerator and denominator have no common factors other than 1. So this is kind of like reducing fractions. If we look down here, we see 15 over 65, and we know that we can reduce that because you can divide the top and bottom by 5 to simplify that to 3 over 13. We're going to do the same thing with expressions. So over here, we have 4 times x plus 3 over x minus 5 times x plus 3. So that's why we can cancel out the x plus 3's, and this is your simplified expression. Now, I want to point out that if let's say the top said 4 plus x plus 3, then we couldn't simplify this because of that plus sign there. Or if the denominator said x minus 5 plus x plus 3, we couldn't cancel off the x plus 3's on the top and bottom because of that plus sign. So it's really important to pay attention to what you are given. So let's get rid of this. So simplifying rational expressions usually takes 2 steps. We have to factor, and this is the reason why we spent so much time factoring the numerator and denominator. So if we have this expression here, we know that we could factor the top by taking an x out, and we would be left with x plus 7. And with the denominator, you could write it as x times x, or just know that, oh, x squared in the denominator means that it's really x times x. And then we divide or cancel any common factors. So like I was saying, if it helps you to write the x as separate, x squared in the denominator here is x times x, you could do that. Or like I said, if you just had x squared, you could say, well, x to the first over x squared, and use your properties of exponents and say, well, that's going to give me x plus 7 in the numerator, and it's an x to the first power in the denominator, and that's my simplified expression. Down here, example number 1 is already factored. So we could say, all right, let's cancel out the x plus 1's, and we're going to be left with 2 over x plus 3. Done. Example number 2, we can see that the denominator is a difference of squares. So we're going to have x plus 4 in the numerator over x plus 4 times x minus 4. And because x plus 4 is the only thing in the numerator, you don't need parentheses around it. But if it helps you to do that so you can see that these are going to cancel, you can do that. Now notice that there's nothing on top. It is not 0 over x minus 4, because if you were to divide that, that would be 0. And you'd be saying that these two things are equivalent to each other, which they're not. So if there's nothing left on top, it's always 1. This one, we got to factor the top and bottom. If you factor the top, 2 numbers that multiply to 16 but add to negative 8, x minus 4 times x minus 4, over 2 numbers that multiply to negative 24 but add to positive 2. It's negative 4 and positive 6. So then x minus 4's cancel, and we will be left with x minus 4 over x plus 6. So you can see that this simplifying makes life a bit easier Because what if I had asked you to evaluate or plug in x equals -2 into this equation here? There's 4 different x's to plug into, and we're dealing with some negatives and squaring that. Very easy to make a mistake. But if I were to tell you to do that and you'd simplify it first, now that becomes very easy for us to do, to plug in -2 and get our solution. All right, on the next page here, I want you to pause the video and try these. Just remember your difference of squares and your factor by grouping when you're trying to simplify this. All right, so these are the answers you should have gotten. On the first one, you might have struggled a little bit with that because we're not canceling out any of the stuff with parentheses or anything with the x's in it. Once you factored out the 20 on the top and the 10 on the bottom, then we could reduce 20 over 10. Now you also may be asking, why are there parentheses on the top and not the bottom? Because we need the parentheses to note that if we wanted to expand this or do anything else, we would have to distribute this 2 in. That's why the parentheses are still there. Middle one, you had a factor by grouping in the denominator, and then cancel out the x plus 3 common factor, and you're left with a simplified expression. And then the last one, you had 2 difference of squares. X to the 4th minus 81 is x squared plus 9 times x squared minus 9. Then x squared minus 9 is a difference of squares to give us x plus 3 times x minus 3. And we could cross off only the x squared plus 9s. We cannot cross off the 3's because these 3's are in parentheses. If we had a 3 out here, then yes, you could cross off the 3's or cancel them out. But we do not have that. Now let's look down here. We're going to be multiplying rational expressions. And this is where your properties of exponents are really going to be used. Remember, when we multiply fractions or rational numbers, we multiply the numerators or the top together, and then we multiply the denominators or the bottom together. And then we simplify the expression. So if we look at this example down here, we have 5x squared over 2x times y squared times 6x y to the 3rd over 10y. So we're going to multiply the tops. So we get 30. X squared times x is going to be x to the 3rd. We have y to the 3rd over 20, 2 times 10, x, y squared times y is y to the 3rd. So we can cancel out the y to the 3rds. We can also simplify 30 over 20 to 3 over 2. Now we have an x to the 3rd on top over x squared. Sorry, we have x to the 3rd on top over x. That's going to simplify to x squared on top. And this would be our simplified expression. So down here, we have some expressions to simplify. So we're going to multiply straight across. This is going to give us 12x to the 4th times z to the 5th over 30. Now, it doesn't matter if I write y to the 5th, z to the 4th, or if I flip-flop them. I just always like to write them in alphabetical order if I can, just so things will line up. You don't have to, though. So we simplify the numbers first. 12 over 30. You get 2 over 5. And then I don't have any x's in the denominator to cancel off, so I'm just going to leave x to the 4th. I do have some z's. I have z to the 5th over z to the 4th, so that's going to be z to the 1st power. And then in the denominator, I have y to the 5th. Like when we combine like terms, I was showing you guys that you can underline things to make sure you use everything. You can do the same thing here, because it could have been very easy for me to forget this y to the 5th, because I worked with the numerator first and then the denominator. So just be careful of those things. All right, example number 2. Now, you could do 9 times 32 and 8 times 27 and then simplify that fraction. Or you could leave them separate, but then also group them or line them up a little bit differently. So let me show you what I mean by that. Like I said, you could just multiply 9 and 32 and then 8 and 27, but I'm just showing you that what if we did this instead? So there's a numerator, and then the denominator. What if I rewrote it like this? And then said, oh, 9 over 27, that's 1/3. And then 32 over 8, oh, that's 4 over 1, or just 4. And then worry about my exponents, or sorry, my variables. Y squared over y is this going to be y. So then your answer, your simplified radical form, is going to be 1 times 4 is 4, so we have 4xy over 3. So we got it a little bit quicker, but you may not always think to rearrange this to line things up. Just know that you don't always have to do it that way. Right, please try the solo over here. I'm going to ask you to pause it, and then work on it. Once you're done, unpause it so we can see what you get. All right, so you see in this one, I did multiply 4 and 6 to get 24, and then 2 and 20 to get 40, because I knew that I could simplify 20 over 40 pretty easily, dividing the top and bottom by 8. So I'm just going to show you that both ways work. And then I simplified my variables to get 3x to the third over 5y to the third. All right, so now we're going to take that and apply it to variable expressions in factored form. So first, if the form is not factored, if the expression is not factored already, we need to factor the denominator and numerator completely, and then cancel out the common factors like we did before. And then we can multiply numerators and denominators to create a single fraction. Now remember, simplified answers are written in complete factored form. So if we look at these examples here, right, we want to factor the numerator and denominator first. We can't factor x minus 4, it's already done, but this is the sum of two cubes. So we can rewrite this as x minus 4 over, your a would be x, and your b would be 2, because the cube root of 8 is 2. So when we factor that using the sum of cubes formula, we're going to get x plus 2 times x squared minus 2x plus 4. And that's all multiplied by x squared minus 2x plus 4. And if it helps, you can write over 1. So now that we're multiplying our two fractions, notice how we have x squared minus 2x plus 4 on the bottom and x squared minus 2x plus 4 on the top. Those can cancel, and we are left with x minus 4 over x plus 2, and that would be your final answer. Over here, we're going to factor out from the first fraction, factor out a 3x. So it's going to be 3x, and we're left with x minus 1 over, factoring the bottom, x squared plus 4x minus 5, two numbers that multiply to negative 5 but add to positive 4, x plus 5, x minus 1. And then worry about the second fraction, factor the top. That's going to be x plus 5 times x minus 4 over 3x. Now again, because everything is being multiplied, we can start crossing things out. We have a 3x on top and a 3x on bottom, so we'll cross those out. We have an x minus 1 and x minus 1, x plus 5, x plus 5, so we are left with just x minus 4. Over here, I want you guys to pause the video and try this one. Remember, factor the top and bottom first, and then combine everything as one fraction. All right, now this one, let's factor the first fraction. Now notice it's 20x minus 5x squared. And we've always dealt with the leading coefficient in the front. So when I factor out a negative 5x, I'm going to rewrite that as x minus 4, just so it's the way that we are used to seeing it. And then in the denominator, I'm going to factor out an x, and we're left with x minus 1. Now my second fraction, we can factor that to x plus 4 times x minus 1 over x plus 4 times x minus 4, because this is a difference of squares. So now I can start crossing off stuff in parentheses on the top and bottom. I have x minus 4, x minus 4, x plus 4, x plus 4, minus 1, minus 1. Now, for this negative 5x over x, because, again, everything's being multiplied, you can cross off just the x's, and you're left with negative 5 as your answer. So to divide rational expressions, it's going to take some of the skills that we use for multiplying. So we're going to multiply the first rational expression by the reciprocal. Now, what does the reciprocal mean? If you've forgotten, the reciprocal means you're flipping the fraction. So if we're dividing, what we're going to do is we're going to flip the second fraction and then multiply. So if you look down here, if we want to do 2/5 divided by 7/3, we change the division to multiplication, and then we flip the second fraction. Same thing works over here. We have a dividing, so instead we change it to multiplying, and then we flip the second fraction, and then we do what we did above. So if you're comfortable with multiplying, you're going to be just as comfortable with dividing. So down here, first thing we'll do is recopy this down, but change the second fraction to its reciprocal. And then we can multiply across the top and bottom. So we get 30x to the third. Whoops, this should have been y to the fifth, not squared, sorry. So then it becomes y to the sixth when I multiply, over 2 times 6 is 12, and then we have x, y to the third, and z to the sixth. And then we can simplify this. 30 over 12 reduces to 5 over 2. Our x's, we have x to the third over x to the first, so that becomes x squared. Y to the sixth over y to the third becomes y to the third on top. And then z to the sixth power stays in the numerator because we don't have any z's. Sorry, z to the sixth stays in the denominator because we have no z's in the numerator. And then this example, multiply by the reciprocal. So let's do, I'm going to split these up, and do what we talked about earlier. Oops, not. Because what I can do then is 40 over 8, that's going to give me 5. And 7 over 21, divide the top and bottom by 7. You're going to get 3 in the denominator. X to the first over x squared means we're going to have x in the denominator because 2 minus 1 is 1, but we have more x's in the denominator, so my remainder of my result goes in the denominator. And then y squared over y, 2 minus 1 is 1. We have more y's in the numerator, so my y is going to stay up here. So that would be my final answer. Okay. Now over here, we have factorable expressions, so let's look at that. This up here, we need to factor with our grouping technique, or you could do guess and check. So two numbers that multiply to negative 30, but add to positive 13. So 3x squared. Those two numbers, oops, not plus. Oh, we need plus. Now, the second fraction here, you can see that there's actually no fraction bar, so we're going to just flip it, and it becomes this. Now, you might say, well, can't I just cancel 3x squared minus 2x? Can I just cancel those? You can't because of these addition and subtraction signs here. So we're still going to have to deal with this and factor it. And we're going to factor by grouping. Oops, I forgot the x here. So factor out a x, and I'm left with 3x minus 2. And then from the second one, factor out a positive 5, and I'm left with 3x minus 2 over 6x squared times 1 over, and I can factor out an x here. Now in the numerator, I'm going to have x plus 5 times 3x minus 2 over 6x squared times 3x minus 2. Now I can cancel off these two things. Oops, I forgot the x here. So now this becomes x plus 5 over 6x to the third, because x squared times x is x to the third. And that would be our simplified answer. So let's go to the next page, please. And I want you to try these 4 problems. And then once you're done, unpause it and you can see what I got. All right, so here are your answers. I showed the work for the first 2 so that you can, again, get another idea of how to do it. But then the last 2, I just have the answers there. So if you have any questions on those, just make sure you ask me about them. So thank you for watching the video. Make sure to like and subscribe.